recording. Morning, everyone. Excuse me. Let's see.
Jeff?
Elaine, you're on for BMC Security round 2, right?
Yes.
Very good. I don't see Darpana on yet, but
Yeah, I'm puzzled.
I'm here.
Oh, there you go.
Sorry. Yeah, I just have to join from my phone because, traffic's really bad. Just didn't get to my desk yet.
yeah, no worries. Also, before we get into that, just next week, a lot of folks are not going to be available, so we're going to cancel next week's OCP call. And that means that today is the last OCP security call of the year, so we'll reconvene in the new one. But yes, I'd let everyone know. So, Elaine, feel free to take it away.
So can I share? I don't think, can you let, oh, there it is. I see it. Thank you. Maybe. Sorry, I'm getting it together here.
No worries.
Just a second. Okay, let's see. Can you see my screen?
Yes.
Okay, and that means you can hear me because you heard my question. Okay. So, let's see. I don't think I'll go through the background again because we went through that last time. Where we left off, I sent out a summary of the decisions, or at least the conclusions that we came up with in the last discussion. And I will go over those. So number one was, are we trying to document the journey along the way? How are we going to get where we need to be, or the North Star? Meaning we really want to document the final configuration of how we want the secure BMCs to look like. So the decision was that we are documenting the North Star with some intrinsic security pieces that were important to be there. Those being the root of trust, an SPDM responder, and a unique protected identity for the BMC. Okay, the ones that are 2, 3, 4, and 5 we have not discussed. Number 6 was, do we stick with DICE, or do we want to allow some other kind of cryptographic based identity? It sounded like most people did want DICE, but they didn't, but others did not want to standardize on DICE itself, because it was not necessary to have a DICE in order to accomplish a custom crypto identity. So that was the decision, and another conclusion was, if you are implementing SPDM, don't do it in ROM. Alrighty, number 10 was, are we going to try to follow what OpenBMC has already, or just some kind of generic BMC? The overwhelming answer was OpenBMC where we could. Number 11 was, some BMCs will handle their own integrity assurances like secure boot and verified executables on their own, or will we rely on an external root of trust? And since there are different ways of doing it, then we will document that either way will work, but it has to be done in order that the BMC. Oh, I'm sorry. This says the document will say, how does it secure itself? It has to be one way or the other, and it has to include secure boot and it has to include recovery. So it could be either way, but it has to be documented. Okay, number 12 was, will we require attestation outbound to the rest of the system? And yes, the BMC would have to act as an SPDM responder and have its own measurements going outbound to the rest of the system. Number 13, will we require the BMC to aggregate all the measurements of the other devices? And that was no, we won't require that. Number 14, will this document that we're writing be a compliance document against which things can be tested or reviewed? And the answer is no. It will be like our prior white papers on secure boot and attestation and recovery and update. Their documents, but not compliance documents. And we didn't do 15. So far, so good. Any questions?
Yeah, I'm remembering the dice conversation. I don't remember that bottoming out entirely, but my memory might be spotty. As I recall, we discussed that like there are alternate schemes for how to do attestation. I don't remember a discussion of like all the pros and cons of the various schemes.
Yeah, I don't think we did go through all the pros and cons. Just that the discussion was we don't want to mandate dice.
Right, and so I guess I'd like to kind of understand the reasons why one would reach for a different one. Like, I'm not saying there's not. I'm just trying to understand what they are, or at least for those who are. Let's see. I think Brian, you're on the call. I think you were discussing the other schemes.
Yeah, I'm on the call. Yeah, I don't think this document goes into all the details on the various schemes. Like Elaine said, it asks for attestation. It doesn't specify dice.
Okay. So I mean, I guess I'm trying to put my BMC vendor hat on and trying to understand when I read this document, am I going to be guided in one, or how am I going to decide which scheme to reach for?
I think the way I would look at it, Jeff, is that we won't mandate one way or another, right? We would say this is the recommended. There are multiple options. The actual requirement is to have a unique cryptographic identity, and how you accomplish that. DICE is the standardized way to do that today. But if you have another mechanism, then that's A-OK as well. I think that's what we would say, right? So up to the BMC vendor how to decide which path to choose. We could potentially say that there's a recommended standard. DICE is that standard, right? There is no other standard for that. So then you're guided towards one way potentially, but not mandated towards implementing DICE. That would be my approach. But open to
DICE. I think DICE is limited to a certain degree for BMC. Like if you think about the BMC stack, it's like a little mini operating system, right? So you're using DICE purely for identity or for more. It's it's not going to be very conducive for a BMC vendor to choose DICE as their conducive to the current software ecosystem, to use DICE for their BMC attestation.
Mm-hmm.
Because Linux, when you look at the operating system and you look at the integrity architecture in the operating system, everything in Linux today is based around a TPM.
Right. So for the same reason you wouldn't just give a DICE identity to a regular Linux node, a compute node, you wouldn't also give it to a VMC, is what you're saying?
Not just the identity, but the software stack in the VMC is geared towards measurement via a VMC because it uses the Linux stack. So
via TPM.
That software ecosystem, if you look at OpenVMC, software ecosystem, if they choose something other than that approach, they have a much heavier lift.
That approach being a TPM?
Yes, if they choose anything other than a TPM, they've got a heavier lift.
Mm-hmm. And that's also fair. I mean, on our side, we also use TPMs, although we use them in, I mean, a bit more of an interesting way. It would be nice to standardize those, but like a lot of it's, I get the sense that a lot of people who reach for TPMs end up kind of building something somewhat bespoke. It's a lot of Legos, and people put them together in different ways.
Yeah, I agree. I think that this it's a typical standard. It's got a gazillion flows in it, and some of them are useful, not all of them. And I think what happens is people generally implement the flows that are useful and not the full stack. I think from like the TPM standard in our implementation, we use about 20 commands, just slightly less than 20 commands. But the spec supports like significantly more.
I'm hypothesizing here, just wondering is there room for a, hey, here's how you can do BMC identity attestation with a TPM. Here's a cookbook that uses 20 odd commands, and then just make sure your software does it this way. That would require people to mold their flows around that cookbook if they want it to be useful. I don't know if
there is a good opportunity for that end to end, not only the explanation, but also the reference for accomplishing that.
For what, sorry?
A reference, like a software reference for how to accomplish that.
Oh, it comes.
Yeah, at lower levels, it may do DICE and stuff for the firmware aspects of the VMC, and then switch to using TPM for the operating system and application, and the user mode stuff.
Right. You can do like a Project Kirkland flow. So
yeah,
low levels.
Exactly.
I see a comment from Rob Wood. Rather than mandating any particular identity implementation, does it make more sense to describe the properties that the BMC requires of any particular identity solution? Leaves it open for the implementation to be more varied without any additional baggage. Perhaps.
So I didn't want to interrupt the flow of the conversation, so I put in the chat. But yeah, basically, if you don't require the full implementation of DICE, if you only require particular pieces of it, then maybe describing those particular properties makes more sense, because obviously not every system implements DICE, and so requiring that they do so would be a heavier lift.
But I get Jeff's point. What I see come across my desk almost on a daily basis is poor implementations of attestation. Keys leaked, critical things not measured. It's just for something that we all believe is like trivial and simple in the wild, it's just not done like that. So I think what Jeff is saying is get precise and crisp and try to limit the pokiness that you kind of see in these.
Right, like there is a wide solution space of ways that it could be done and would fulfill the requirements, but there's an even wider space of implementations which really wouldn't fulfill the requirements. And it would cost energy to tell one from the other. So
then I think documenting the requirements, somehow in a clear way sounds like it's important. Like, all mutable firmware must be measured, or et cetera. Whatever the list is, what state must be measured. If there's, especially if you're seeing inconsistencies in what's measured, what is the list in a.
Putting myself in the like a chip vendor's position, if I have a choice of implementing DICE or documenting what I've already done according to your requirements to show that I've met that, like I still have to do the work, but one of them might be less work. And I agree it takes work to prove that we've done the right thing, but if you have the requirements all listed in detail, then we can at least document against that as a standard. Whereas implementing DICE instead of what we've already got might require ROM changes, all sorts of things that are insurmountable.
Okay, so I mean, we could riff further on this direction. Elaine Darpana, I don't know if you wanted to cover anything else. I feel like I just kind of co-opted the flow.
Yeah, I think having those requirements specifically of what do we need for identity and what is it trying to accomplish, why is it there, is important. But having DICE specifically might really screw up a lot of people.
Mm-hmm. Yeah. There's an interesting difference in shape of attestation between, we've been talking about TPM based attestation, where you give the Linux stack its identity with PCRs and maybe cryptographic sealing perhaps, whereas that's a little bit different than an SPDM responder, where the way I visualize that is there's a small trusted execution environment isolated from the main Linux runtime within the BMC, which knows the measurements of that BMC and can report what they are. And that's basically all yes, SPDM can do secure sessions, but I'm not aware of any concrete use cases where I want to do a secure session to a BMC SPDM responder. The more concrete use cases I can think of are, I want to know what the BMC's measurements are. Please tell me.
Yes.
So I feel like either we do that with TPM or SPDM. I do not see a solid need to do both.
Yeah, or in fact, I had a slightly different view, which is that you could use what was in the TPM to be using those measurements reported via SPDM.
How's that work?
But then you still need your signatures and the challenges and so forth. So I don't know. Is it the protocol itself, or is it secure measurements, right, that we're after? We probably want the protocol, because if we don't specify a protocol, then how can people have a standard that they can interact with, right?
But there has been some work on the redfish space, right, to allow exposure of TPM measurements.
Right.
So it's kind of intertwined between redfish and TPM. If you have both, then there is an existing way, and there was proposal to extend that to extract BMC TPM measurements.
That would be pretty cool. We stick with, but redfish is the medium to do it, but it's sending the challenges, the requests for quotes, and then sending the responses back.
Yeah. And I guess what I was earlier talking about when I said don't do TPM and SPDM both, what I guess I was thinking about the BMC's own measurements. like the existing SPDM redfish bindings were envisioned to facilitate the BMC to go ferry other devices' measurements off.
Oh,
Like, as in, I'm a BMC and I'm an SPDM requester, and there's a bunch of SPDM responders over on the board. I'm going to go challenge them and give their measurements off of redfish, was the idea.
oh, not for itself. So
I mean, hypothetically, you could do it for itself. If, like, imagine the BMC, like, there's a trusted execution environment that has the SPDM responder isolated from the Linux runtime. Linux runtime can act as an SPDM requester to quote unquote itself and say, what are my measurements? And then give them back. That's one way to doing it. Or if all those measurements exist in the TPM next to the BMC, then you can ask the BMC to go quote those measurements.
yeah, what's interesting about when you say ask the BMC, it brings me really to another one of the questions that just really screws up my head, which is on, let's see if I find it. It was the interfaces. Yeah. Okay. So 2 and 3 sort of go together, these two questions, because when I look at asking the folks who work on OpenBMC, tell me what are all of the possible access points into the BMC? Well, you know, you have your physical access points, and then you have your logical access points, and they don't necessarily, some of them overlap. So you might have a serial interface, you might have the PCI interface, you might have a special JTAG interface. You have all kinds of ways to get into this poor little device. And then on top of that, if you're going through the full stack that's there and you're using Linux to handle your commands and, you know, whatever it is, your interactions, then you've got the Linux access controls that are doing users and groups and the typical stuff that you do in Linux. And it's like, how do you get a handle on all of these possible ways to get in there and control access to the assets that are in there? So sorry, you pushed my button there on that one. Because
sounds like we need a picture, a graph to document all of that.
Yeah, and I started doing that, and it looks like a spider web. I mean, it's terrible. The thing that would be nice is if you could always go through Linux, which is yet another question on there, which is, are we going to, if we're sticking with OpenBMC, which runs Linux, well, then you know that you'll have a Linux stack in there. And could you always rely on that to handle your requests in and out? But then with the BMC always being available, you know, power-wise and responding to some central management system, is Linux always there to respond? It may not be, right? I mean, I don't know. I need some other heads to weigh in on how we control these interfaces, including roles and assets that they can manage.
That
so
sounds,
I'm listening.
Yeah, that sounds really valuable to nail down.
I did want to talk about like making sure that we nail down at least the identity and the attestation parts of it, because we have had 2 topics on this. So how do we kind of converge on that topic?
I guess which entity is requesting identity from the BMC? This is like the host SOC or host OS or something is requesting it, or because it sounds like it could come from 2 directions. It could come from outside via like Redfish or something, or it could come from some other entity, I guess. So when the BMC is an SPDM responder, you know, who's the requester in that case?
Right. I'm imagining. So so far we've kind of shied away from doing SPDM over the network. SPDM has been like an intra box protocol. So yeah, if the BMC is an SPDM responder, then who's the requester? there are platform architectures where you have like an internal hierarchy of BMCs. Like there's a BMC for a particular tray, which is subordinate to the main management node. And so the management node could go and say, hey, BMC, give me your measurements, need to check that they're good. And it could be doing that on behalf of the control plane.
So I didn't see who asked the question, but maybe could you clarify the purpose of the question? Like, I don't see any real difference between those two use cases. Both the host and the network are outside the security boundary of the BMC. So in either case, it's some outside entity asking for that information.
Yeah, I guess you were talking about on point 6 about the BMC identity and so on, and I guess it's providing attestation of its state and measurements, etc. And I was just wondering, yeah, what direction that's going. Maybe it doesn't matter, but I guess because one view is that it's the BMC who's kind of in charge here and is requesting measurements of everything else, right? Of devices and so on, and it's a requester and accumulating measurements that it could then report out somewhere. But I guess what we're saying here is that it also could, another paradigm, I guess, is that there's somebody else, some other entity is going around to all the SPDM responders requesting measurements, and the BMC is just another one of them. It's like another device or something. So I'm just trying to understand the paradigm that we're thinking about, or if maybe there's more than one.
In our case, and I can only speak for how we would use it, it is used within a system to it's at different levels. By itself, it can gather, of course, the measurements of the other subordinate devices, but as itself, it has to attest to its host. And I know that others may use things differently, like the BMC may represent the host, right? And so the host is just this anomalous thing that, I don't know. But the BMC for us is subordinate to our host, and so it has to attest to its host. In a data center, I'm sure that's very different, right? Your BMC is the one that's doing the attesting, right?
Yeah, there are a couple of different integration patterns we've got. Like in one case, we treat the BMC more as just like a pass-through gateway, like it's a subordinate. We don't try and interact with it TPM to give it like a full-fledged identity that's bound to all the measurements within it. I mean, we we expect it to be an SPDM responder, so we can challenge it, say, hey, the measurements are good, as at least the boot firmware is good, and we would expect those measurements. Like it's not like doing a multi-stage boot. If it was, then we won't want those measurements to be deposited into the SPDM responder. But we're not requiring like a full sealed cryptographic identity. It's like not on our network. In other cases, it is on the network and has a like the Linux stack has a credential bound to the TPM.
So you do it both ways.
Yeah.
Okay. Yeah. So I guess the answer is that there's not just one way here. So.
No, it'd be nice if there was, but no, I don't think so. And another way to think of it is the fact that just because we're talking about a BMC doesn't make it so special in the world of devices and devices within a data center, because with your memory might be somewhere else and you want to attest that, right? It's not even in the same physical box, it's somewhere else. And if you think of all of those things individually as needing to attest themselves, in my view, the BMC is just yet another one of those. And so why wouldn't it follow SPDM?
I could imagine So in our situations where we got like a subordinate BMC, which doesn't need a network identity, like SPDM is there, like we're using it. I don't know if like we necessarily require it to be SPDM shaped at that point. Like if those measurements were in a TPM that we can ask the BMC to quote to us, that I think would work too. That's just it wasn't as well socialized or defined, I think, especially like how to get first instruction integrity, right? I think that's one of the requirements is if you got like a passive TPM on the side and it doesn't receive any measurements until a substantial amount of code has already booted on the BMC, that's not ideal. So that's where DICE and SPDM gets a little bit more attractive, where the earliest boot code, or if you got like a discrete EROT that can measure the flash, I know it's kind of like a bit of an older architecture, but it's serviceable. And then just say, hey, what measurements were there? You got an integrated root of trust. You also want a DICE identity for that, or rather, sorry, we don't need to,
unique identity.
We need an identity that factors in the first mutable code, and then some well-defined protocol to use that identity. SPDM is one of those protocols. Project Kirkland TPM is another, although I think that's a little bit less well-baked standards-wise. Like we know what the rough moving parts are, but it's not fully written down in a rigid way.
Another thing that we do is that, let's see, I think that Brian calls it the journey, not in this case, but the journey of, we do dynamic measurements. So by taking advantage of the Linux stack in there and integrity measurement architecture that comes free with it, we can do dynamic measurements. We don't have to rely on just the snapshot at boot time. So, and then and in that case, we are definitely using the TPM style.
All right, because like every time you do a runtime update, you'll extend measurements into a PCR.
Yeah.
We have SPDM 1.3 is gaining the ability to do PCRs, but I think TPM it's more of an ecosystem. So
and we have the verifiers and all that outside.
It's a whole thing.
Like you said, an ecosystem. But if you are I don't know, carrying that communication through Redfish, it seems like that's a convenient way to get there, but it's not necessary. But it's helpful.
Redfish is the pipe, but so like just breaking down to requirements, right? We need first instruction integrity, and we need the well-defined the identity based on that those first instruction measurements. We need a protocol. So DICE is one way of capturing those measurements into identity, and then SPDM is one way of using that identity in protocol, and then there are Redfish bindings there. That as we just said, there's not as much of an ecosystem for managing hitless updates that way. It's getting there, but it's not there. So the other way is, all right, there's a TPM involved. Now, if the TPM is discrete, then we would want still to capture the first measurements of the BMC firmware before the TPM, before enough code is run to actually interact with the TPM. Although I'm aware that some people are putting TPM code in ROM, which is interesting. But cool. But Project Kirkland is another way, just like do DICE and then transition into TPM at some point. Another way I can think of is just have an integrated TPM, and those first measurements get turned into PCR extensions, which an interposer can't mess with.
So you're on number 4, which is
Right.
If you have an integrated TPM, meaning like a firmware TPM that's running there.
Or a subset of TPM, right? You don't need entire TPM here. The focus is identity and the measurements. So some of the BMC implementations implement only subset of TPM functionality.
Yeah.
So that gets into like, yeah, TPM is a very wide protocol API. And people typically use smaller subsets of it. I'm curious what a subset is that you're referring to. Is it basically around coding PCRs?
Identity as well as measurement reporting, PCR equivalent functionality. And identity can be ID.
Sorry, I have a bit of delay. In my experience, TPMs are extremely common on x86 systems, but extremely rare on ARM. So we see a lot of things that are TPM-like, but not TPMs themselves.
Let's see.
In those cases, would they have those two functions with the unique identity and the ability to collect and report measurements?
Yeah, those two things specifically are what we would see. And that's usually in some sort of like firmware TPM or something along those lines.
And they follow the TPM, the TCG protocols?
Some do, some don't. It's a little bit more variable.
They don't have to follow exactly TPM protocols. I think what you really need here is strong identity as well as way to report those measurements. At higher level, they can use TPM protocols or Redfish, whatever it happens to be, but key is to provide those measurements in a secure manner. I guess number 4 should also include TPM equivalent kind of thing. I don't know, we need to come with the right terminology, but partial TPM or subset of TPM equivalent functionality implemented within the BMC.
In practice, how are these subsets arrived at? Basically just conversation with customers. What do you want to do with the TPM, and we'll make it?
In the cases I'm aware of, that's basically if there's a specific, say Redfish feature that needs to be implemented, how that's implemented underneath is not terribly relevant as long as it meets that Redfish API requirement.
Mm-hmm. I guess what I'm getting is like there do exist TPM profiles that TCG publishes, PC client and server, which is basically PC client. Sounds like these are in practice, these are other profiles that are floating around out there, although they're not really standardized. They're just like what a particular vendor and set of customers agreed upon.
Yeah, like from a customer perspective, if you're requiring that the system support Redfish and a specific list of Redfish APIs that you're intending to use, then how the actual vendor implements those under the covers is largely irrelevant. There might or might not be a TPM underneath there, as long as it meets the the API definitions.
Right. Yeah, I think putting my data center attestation hat on, like I would care about not only like do all the Redfish commands exist, but also if I'm going to be interacting directly with a TPM API behind that, I do need to care about the API service of that TPM. So this is kind of telling me that maybe we need to get our heads together and figure out what is the set of TPM commands that we all would like, and write that down so that we can have a common API surface.
Yeah, and that we could do as a section of the document, which is what are the TPM commands it should support.
Right.
Okay. There is an intriguing comment in the chat from Ludwig from NVIDIA, and it says there is a TPM profile for BMC. I'm intrigued by that. Can you talk about that some more?
Yeah, well, I think it's obviously a public document, but it's basically TCG usually defines two types of profile. What is called a TPM profile, like the set of commands a TPM for a particular set of platforms like PC client or server needs to support. And then there is basically the equivalent of UEFI secure boot. So how the platform firmware is using the TPM to store measurements. And so this particular server working group specification is the latter. It defines how a BMC stack should store measurements in which PCRs if a TPM is attached to a BMC, either being discrete or integrated or FTPM. So I think it may be relevant to that.
Yeah,
document,
definitely
right?
so. And does it include the responses as well? You know, that it has to support, for example, a quote request? Or is it only how to store the measurements?
Off the top of my head, I don't remember, but I see Shiva, who is one
Yeah.
of the author, so he can describe exactly that.
Yeah, so Ellen, basically it assumes that the TPM is same as the PC client TPM. So everything that is allowed there is also allowed here, including core operation that you mentioned. What TCG server management domain profile spec documents is mainly which measurement goes where and what kind of things need to be taken care during reset, those kind of things. There's many other things, but mainly it provides a way along the line. PC client platform firmware profile provides where PCRs are allocated to different firmware components and external entities. When they get those measurements, they will know based on the spec which measurements they are dealing with.
Okay. I got it. So we need that, but we need more than that. Right.
I think if somebody goes with the embedded, the TPM approach, discrete TPM or firmware TPM approach, that spec will help to get some commonality across the board and helps with the attestation.
Okay, so
right.
Use the firmware TPM as a model. And we want to see this TCG document for what to measure where. And then we need a list of the TPM commands. Right.
The commands supported by the PC client TPM are also supported here. TPM supports them, but which one of them we use depends on the use case here, right?
So you're saying it's going to have to support all of them that the PC client does?
TPM is exactly same as what you use on the in the PC client or server host side. The standard TPM. TPM is exactly same. So every command that TPM supports is available here. You may or may not use in the context of BMC. Quote is obviously used for getting those measurements, but there are a bunch of other commands we may not use, but they are available. If you want to specify which ones we need, we can go and do that. But what I'm trying to say here is that the TPM, here is the standard TPM, so everything is available.
So for those ARM-based platforms that have TPM-like functions, are you saying they should support the whole?
That's where the things get tricky, right? I think the subset one, where you added a TPM subset, mostly identity and measurement related functions such as PCRs and everything associated with it, codes and all that stuff, signing and all that, those functions are the one supported. Essentially, whatever required for identity and attestation are the ones typically supported.
Yeah, but is there any kind of document that
I'm
has
not
that
aware of any
subset?
document. I think the implementers picked up the functions related to those and implemented those. Wherever some BMCs probably went ahead with an approach of embedding TPM, but other BMC vendors decided that I don't need this whole heavyweight TPM. Only thing I need is these 2 or 3 major functions of a TPM, and let me implement those. I think that's where the TPM subset comes into picture.
Yeah, and some use the whole discrete TPM.
Right. I think if exactly, yeah, a discrete TPM or firmware TPM, either embedded, or you can also connect a discrete TPM to BMC and make all of these functions available, right? I think that is allowed as well.
Yeah, because then you get the other useful functions of some secure storage and things that come free, your crypto random number generator that are there as a nice convenience.
That's right. And some BMCs already have those secure storage and random number generator and bunch of other things. They went ahead and added additional things like identity and PCR equivalent functionality. But I agree with you. I think if you have TPM connected, you get many more functions. But unfortunately, or fortunately, whatever, because of cost and other reasons, some BMCs chosen to implement subset of this TPM functionality.
So we heard that these ARM-based TPM-like subsets, are those documented anywhere? Someone who's familiar with that? Do you have documents that can be shared publicly?
I was the one to mention that earlier. The ones I've seen are vendor specific, and I can't share those documents publicly. But I don't know, maybe reach out to some of the vendors and see if they want to release them. Most of them are available under NDA. I've only seen 2 or 3 myself like that.
Yeah, that would be helpful.
I'm from ARM, and I guess what I'm aware of is like on the much lower end devices, you know, like IoT devices, there's like a standard called the Platform Security Architecture, PSA. There's some attestation APIs used there. I think they also in that space are using like this IETF EATS attestation standard. But on the kind of higher end systems, I guess I'm not aware of what's being referred to as far as TPM subset functionality. You know, so I guess I don't know from the ARM perspective. I've not run across it.
So it must be something that those who have ARM-based platforms have added on top of.
Maybe, yeah. I mean, once you kind of get into, you know, higher end 64-bit SoCs and so on, I mean, it's, I mean, I've seen mostly, you know, TPM, you know, based attestation.
Firmware TPMs.
Firmware discrete, yeah.
Anybody else out there who's got, you know, some SoCs with ARMs in them? And they have added TPM subsets.
Yeah, I've seen the PSA only on the ARM, and especially for IoT devices only. So I don't think it's much applicable or directly applicable to the server industry.
Well, then it looks like we're heading for a full TPM command set if we don't have any other way to limit that subset.
Well, I think a discrete TPM is likely to to have most of the TPM functionality at least as defined by PC client, because that's what is widely available. The only other
Right.
TPM profile is an automotive thin profile. So I think for discrete TPMs, yes, you will have everything. But I think if we need to think about subset for firmware TPMs, then we probably have to derive that based on the use cases and look at what TPMs command are used for identity attestation, secure storage potentially, and then maybe people can pick and choose based on the use cases.
Yeah, I find it, I don't know, frustrating trying to help the BMC vendors with, what do they have to implement?
By the way,
nice.
are there BMC vendors that are participating in OCP security by chance? I mean, because I think some of the stuff we're talking about is like, well, we need OCP vendors here, or I'm sorry, BMC vendors, to kind of weigh in on some of this too. Like what are they doing? And
So HPE, at HPE we make our own BMCs. So some of my comments are related to our BMC, but I agree. I think it helps if there are other BMC vendors participate and express their opinion here.
Nuvoton is doing BMCs, sorry, and we're also doing discrete TPMs. And for as much as I followed the discussion here, in our BMC we also have firmware TPM running in the BMC.
Is it the full function?
I'm not sure about that. I think the answer is yes, but I need to check the details just to make sure.
Yeah, I wonder, is it a hardship to require full function TPM of a BMC vendor?
I think it's mostly a question of resources. The difference, I mean, between full-blown TPM and partial.
Yeah, I know that we take advantage of some of the extra features, right, of a discrete TPM. So it makes our lives easier. It makes OpenBMC's life easier.
I already made my comment, derailed the conversation. Maybe the best approach here then is to just publish the recommendations as using the full TPM specification as needed, and then if you get any pushback, we can deal with that later.
True. Yeah.
Minor pushback. And the examples that I was referring to earlier weren't they weren't server things. It was more peripheral devices that would be included in TPM. So it's possibly it doesn't apply. So.
Yeah, I guess so. So it's easier to apologize than ask permission, is what you're saying. Just put the whole enchilada in there, and then we'll see what feedback we get. That's fair. Yep. So it would either be a full function discrete TPM or firmware TPM, but both full function. It makes sense in a way too, because if you're a certification proponent like I am, then you would like to have your TPM certified. And if it's half a TPM, then you can't do that. All right, we only have 4 minutes left, so I suggest we stop here.
Cool. Well, yeah, really good discussion.
I have an admin question when we're all done here.
Sounds like this is the time for it.
Okay. Has there been any discussion of changing the time of this meeting? As it is, very often it overlaps 2 other meetings on my calendar, and if we could move it to, say, the top of the hour instead of halfway through, it would reduce the conflicts to some degree. I don't know if anyone else feels that way, or if the circumstances that originally caused it to be scheduled at past are still in effect. Thoughts?
I don't think that's, I've not heard any discussion of changing the time so far. I don't know, anyone on the call? What other thoughts?
Well,
It
this
it-
does cut across the TCG attestation call.
You say it does, Eric?
Yeah, I usually only catch the first half of it.
Yeah,
that meeting goes was it nine to or
And yeah,
yeah,
it's
9 to 10.
I'm sorry,
No, it's 8 to 9
eight to 9
Pacific.
Right. Right.
I also find that, you know, fairly often there are conflicts that cut across one of the half hours. And so I do think starting at the top of the hour is preferred, unless, you know, if it's possible. But
yeah, I agree. If it were a half hour later, it would be better.
Okay. Good input. So let me, let's discuss this with the project leads. Might put out a doodle or something just to gauge further input, but I'll note that down. Thanks.
Yeah, sounds good. I don't think we want to move too far off where we are right now. Maybe two choices, an hour, half hour earlier, half hour later, and that would be close enough. But, okay, thanks very much, Jeff.
Actually, like, does anyone on the call feel like the opposite? That if it were to go from, say, 9 to 10, that would cramp their style?
9 to 10 would be my preferred.
That would work for me.
All right. I'm not hearing anyone else say otherwise. So
okay, let me be the unpopular one. Maybe, you know, for people based in Europe, it's not ideal. A doodle would be more useful, I would think.
what would be more useful? Sorry.
A doodle or some sort of voting thing. You know, plus minus 30 is fine.
Mm-hmm.
If it's much later than that, might be a problem. Not impossible, but you know.
Yeah, that is true. We should be cognizant of that time zone. I mean, it's yeah, that's like right on top of that's leading up right into dinner time, I think. 9 or 10. It's like 6 to 7, I think. Okay. Yep. Good to factor that in. Cool. Well, Darpana, Elaine, thank you very much for leading that discussion. Very good.
You're welcome. Happy holidays, everybody.
Yes. And see you in the new year.
Sounds good. Bye-bye.
Goodbye.
Ciao.